All right, so for this quick video, we're just going to look at the difference between even functions, odd functions, and functions that are neither. So visually, an even function is a function like our quadratic function, where you can kind of split it down the middle and it's going to have that reflectional symmetry. Another example is our absolute value function. Something that is odd would be like our cubic function, where we could flip it upside down and it's going to look like the same function. Another function that would have origin symmetry, just looking at our functions here, would be our rational function, right? And one that doesn't have any would be like a polynomial that has some different things going on with it. Of course, we could have some polynomials that are even and some that are odd. An even polynomial maybe is like our W function. An odd polynomial might be one that comes in, bumps, comes down, bumps and goes back down. So there are some options there. And then especially things like our log function or exponential function on their own would be neither. But the important part that we want to look at here is these definitions, because today we're going to look at what these functions look like algebraically. And we're just going to go through a couple examples here. And it has to do with finding f of negative x. So in our first example, I'll call this example 1, I'm going to give you the function f of x is equal to 1/2 x cubed plus x. So to find if something is even or odd, you're always just going to do f of negative x. And so what we're going to do is we're going to replace our x's with a negative x. So this would be 1/2 negative x cubed plus negative x, and then we want to simplify this down. So our opposite function here is going to be 1/2 times negative x cubed minus x, which comes out to negative 1/2 x cubed minus x. So when we take a look at this function, this final function, I made this too small at some point. When we look at this final function and we compare it to the one that we were given, you can see that they're the opposites of each other. This one, I just changed from negative to non-negative and negative to non-negative. So this fits our function right here. What we got was we got the opposite of it. So this is going to be an odd function. When I took the function of negative x, I got the opposite of my function. And we'll contrast that with an even one next. So for my next function, or my next example, I'm going to give you f of x is equal to 2x to the 4th minus 3x squared plus 6. Every time we're trying to figure out even or odd, we're going to do the function of the opposite, f of negative x. And then I plug in a negative for each x value in my function. And then I'm just going to try to, simplify that. So negative x to the 4th is x to the 4th. So I get 2x to the 4th minus 3 times negative x squared, which negative x squared is x squared. So I get negative 3x squared. And I get plus 6. And there's nothing else I can do here. Now, when I compare my original function to my new function, they are the exact same. F of x was equal to the function of our negative x. So that is going to imply that it is an even function. But not every function falls into the even or the odd, just like we did in our graph. So let's do a quick example of one that is neither. I'm going to give you f of x is equal to, we'll do our common log of x plus 1. So if I were to try to figure out f of negative x, well, that's just log of negative x plus 1. We can't simplify that. We can't do anything with that. So here we see that f of x is not equal to f of negative x, and it's also not equal to negative f of x. So none of those are true, so it is going to be neither. Now I'm going to zoom out here. I'm going to let you guys in on another little secret, on a bit of like a shortcut. So just like we have some functions that are even, some are odd, when it comes to polynomials, if we look at a function's degree, it says a lot about even and odd. If it has an odd degree, it only has an option of being odd. And if the leading term, so if the polynomial itself has an even degree, it only has a chance at being even. And that's because when you cube or fifth power, or when you put a power to a negative power, a negative number to a negative power, you're going to get a negative number back out, which is going to help us transform positive values into negative values. When we put a variable to an even degree, you're going to get an even number out, and that's going to help us maintain this equality in the beginning and the end. But that does not mean that every time you have an even degree polynomial or an odd degree one that you won't get either. So I'm going to make up an example because the examples I have don't demonstrate this. But if I had y equals 2x cubed plus x squared. So this one has an odd degree, so we're going to see if it's odd. So when I do f of negative x, I'm getting 2 negative x cubed plus negative x squared. So I get really close. This comes out to negative 2x cubed, so I'm getting really close to it being odd. But this one comes out to a positive x squared. So f of negative x is not quite equal to negative f of x there. So this one would be another neither. That one would be discounted. I have 2 more examples for us today. I'll gotta clean this up a bit. Here we go. So in our next example, I lost track of how many we've done. We have f of x is equal to negative 2 times the absolute value of x plus 7 minus 1. Now, we did say that the absolute value function is an even function, but there are some transformations going over here, so it may not be reflective over the y-axis. We need to simplify and see. So in this case, we get f of negative x is equal to negative 2, negative x plus 7, minus 1. Now, you may not be able to look at this and say, oh, those aren't the same, because we have this variable in here. And if we're being confused by that, what I want you to try, instead of using f of x and f of negative x, is try instead f of like 2 and f of negative 2, or 1 and negative 1, just any 2 numbers that would be opposites. This would give us negative 2, 2 plus 7 minus 1, which is going to give us negative 2, absolute value of 9 minus 1. Negative 2 times 9 is negative 18, is going to give us negative 19 as our final answer. When I plug in negative 2 instead, I get negative 2. Negative 2 plus 7 is 5 minus 1. I get negative 10, I get negative 11. And since those are not equal and they're not opposite, this is going to be a neither situation. I promise you, if you tried this and it was even, they would come out to negative 19 and negative 19, or they would come out to 2 and 2. And if it was odd, you'd get 3 and negative 3, and that same rule works. We'll do one more example together just to drive this case home. Let's give us the function negative 1/3 x squared. So if I'm going to try f of negative x, well, negative x squared is x squared, so I get negative 1/3 x squared. When they are equal, when f of x is equal to f of negative x, it is even. And if I graphed it, which would look something quite steep like this, it would have that reflective symmetry. And just to prove my option from the last time, Let's try f of 2 and f of negative 2, just to show you what would happen. This is going to be negative 1/3 times 2 squared, and this would be negative 1/3 times negative 2 squared. 2 squared is 4. We get negative 4/3. And negative 2 squared is 4, so we get negative 4/3. And those are the same, so once again, this is an even function. So when it comes to evens and odds, let's scroll all the way back up here to the top and make sure you have this written down. If it's an even function, not a highlighter. If it is an even function, your function, if you do it for the negative, is going to come out to the same as it did when it was positive. If it's odd, it's going to come out to the opposite. And if it comes out to anything else, it's going to be neither. So that's how you determine even and odd using algebra.